Yeah, very good afternoon, the participants of second year B section. I welcome all of you to the next session of Digital Electronics Laboratory. Because there was a long gap, even today morning I forgot what is the course code, and now I can recollect. It's U19 AZ 212. Uh, Digital Electronics Laboratory is the course. Good. And as far as the statistics where we are now standing in is, we have got 7 experiments. Eighth one is a mini project, and ninth one is the main project. But for time being, we cannot do any major projects or main projects. So we will be planning to go for mini project at least. Okay, and I think Priyadarshi and Rahul Franklin, they will be in their track to get the batch details and titles also. Yeah, Priyadarshi,
Yes,
what's your
sir.
status?
Um,
Okay, see, once you got the batch details, you request them to start doing the mini projects. Okay, one fine day, like your theory papers will have presentation hour in between. Like that, I'll make one presentation hour during this laboratory also. On that day, all the students, you have to present your mini projects. Maybe not individually. If batches are formed, means batch wise, you have to present your mini project. Okay, so be ready for it. So you have given the commitment, like to the Priyadarshini, you are all the batches, means you start working out on the area or on the title which you have chosen and given it to Priyadarshi. I request Priyadarshi and Rahul Franklin to consolidate the name list what they have given and the batch details with their title. I request Priyadarshi and Rahul Franklin to send it to me as early as possible, so that the list will be confirmed and our batches, they will start working on it. Is it okay, Priyadarshi?
yes, sir. I'll send it soon, sir.
Yeah, okay. Okay, thank you. You can take 2 or 3 days time, okay, not immediately. After, after consolidating, okay, after finalizing everything, you try to send it, Priyadarshi. Yeah,
Yes, sir.
Rahul Franklin. Rahul Franklin also has given the commitment. They both will be submitting to me. Remaining batch students, you start working towards your project which you have chosen, and try to be ready because CAA1 got over. I hope everybody you have got your marks also. And tomorrow in our EMF class, we will discuss regarding the marks. Some appreciations will be there because class first, second, and third marks are the students, those who have scored more than 80. There will be some special appreciations. Uh, so that will be done in our tomorrow's class. As I promised Saturday, before Saturday or and on Saturday, we will discuss about the marks I said, and it is ready now. And I think I have returned back your marks in the Google Classroom also. You might have seen. Some of your classmates has called me and asked me why my mark is very less like that, both from A section and B section, and I clarified their doubts actually. There are a lot of common mistakes that were done by all of you that we will see tomorrow. Tomorrow in our EMF class, we will do that. After that, we will go to the actual topic of tomorrow. Fine. Next thing, what I want to convey is we are actually we will be seeing now the recall of what we have done it last week in the laboratory. There is multiplexer and demultiplexer. What we have done in the last week that we will recall with implementations. Then we will go to the starting phase of next experiment. Next experiment is actually implementation of 3-bit parity generator or checker. See, parity generator, other name is actually parity checker. Both are actually same. Very, very easy experiment. Okay. Then also we will verify using Logisim. My plan is to cover the theory portions of what is parity bit, where it can be used, or what is parity generator, what is parity checker, right? Those theory portions we'll be completing by today, along with the implementations of mux and demux. Then on Tuesday, we will be implementing the parity generator. Okay, that's our plan for today and coming Tuesday. Obviously, next Friday will be a holiday. After that, 14th, we will meet again in the laboratory with the new experiment. Okay, that's our plan. And with this particular small brief about the status, I'll present the screen now. Yeah, whether the PPT is visible?
Yes, sir, it's visible.
Okay, thank you. So it is U19 EC 212 Digital Electronics Laboratory. Agenda for today, it looks like this. A review of the previous class questions. That's what we have done till now. Mux and demux introductions. It is not introduction, it is actually recall. You will see. Then implementations using Logisim and virtual labs. That also we will see. Along with that, what is parity? That also I will cover today. Then last session is actually summary with attendance. Attendance, this is a Google Meet platform. So oral attendance will be taken. So once the session is completed, don't leave the session. Be here and give the attendance without fail. This is regarding the course. And this is the syllabus, as I said. So first experiment, prerequisite lab we have covered. It is implementation of, I think it was not implementation, it is verification of basic logic gates. We have seen as a pre-lab. Then we have seen implementation of adder and subtractor using logic gates. And now we have completed implementation of multiplexer and demultiplexer using logic gates. But I hope there will be some doubts in implementation regarding mux and demux. That's why I have taken this particular additional session also. Third experiment is actually implementation of 3-bit odd, even, parity generator and checker. So this is actually, according to the serial, it is 3, but according to us, it is 4th experiment because we have included pre-lab as a separate experiment. Okay. So this also is going to come under combinational logic circuit only, right? And in the next slide, you can see if anybody has got doubt what to select, what title has to be selected for mini projects, you can have this particular slide. Digital score display board, automatic day indicator, 4-way traffic light, electronic cricket match, digital counter. So this will resemble what I said as a project. That is a counter only we are going to design. So in your classroom also, you can design some counters that also can be added here as a mini project. And even automatic day indicator, in the same way, date also you can do that. Digital score display board, instead of it, you can go for digital notice board. That is also is possible. But those titles which I am telling now as the notice board or counter, classroom counter. These titles you can choose it as a main project, not as a mini project. Okay, mini project they have given only a simple experience, right? So these 4 things out of these 4 you can choose any one. Coming to the COs, we are again in this first course outcome only CO1, which is in the apply level. It is implementation of various combinational circuits. So what we have seen till now, like adder and subtractor implementation, mux and demux implementation, and what we are going to cover in the next parity generator and checker, all these things are going to come under combinational circuits. So the course outcome is implementation of various combinational circuits. Here, in addition to what you have seen in the last class, what ma'am has said, I have got some additional points which you might be knowing already, right? Multiplexer, which is also called mux, it may be required to select for some applications. There may be a necessity to select a single input line as the output. So there may be several input data lines available, several input lines available. Uh, there may be a situation that we are asked to select uh, any one out of those several lines. Okay, so if that is our situation, right, then we can go for mux. And the data from the selected data line should be available on the input. The digital circuit which does this task is called multiplexer. As I said previously, multiplexer is also called a data selector because we are going to select a data, a bit from the input, and we are going to route that particular input to the output, and we are going to get the output. Okay, it is also simply for understanding purpose, I can call multiplexer as many into one. What does that particular many is telling you is many inputs are there. What does that particular one indicates you is only one output is there. So many inputs into one output. That is what we are going to do with the multiplexer. Is it okay? Next slide. What are the different types of mux? So we are having, so as far as multiplexer or mux circuit is concerned, when compared with the output lines, input lines will be more. So 2:1, 4:1, 8:1, 16:1 multiplexers will be there. Okay, I'll put you one question. I'll see who can answer it. Like, um, for 16:1 multiplexer, right? There is some additional input lines also required. Along with these 16 inputs, we will be having extra some inputs also. How many extra inputs will be there for 16:1 mux? Other than these 16 bits, how many extra input lines will be there? And what are those lines called? Any volunteer?
Selection line.
Four selections line.
Yeah, selection lines. Very good. So select input bits will be there. So for 16:1, how many extra lines, extra bits will be there as input? You said like selection bit, right? How many selection bits will be there?
4.
Okay, how it is for?
2 to the power n, sir.
Yeah, 2 to the power 16. If you write it as 2 to the power 4, so that particular power 4 will be the number of selected inputs. Okay. Similarly, for 8:1, 2 to the power 3 select inputs. 4:1 means 2 to the power 2, so 2 select inputs. 2:1 means 2 to the power 1, so only 1 select input I can go for. So if you want to thoroughly learn about multiplexers, you should know all these things. What is the block diagram of a multiplexer? What is its function table? What is its truth table? Then by using K-map, how we can derive the output expression. Then we have to go for the logic diagram. Okay, one question to you all, whether this particular topic has been covered in your theory or not yet.
Yes, sir, covered. Sir.
It was covered. Okay, I think we might have got some input about multiplexer. Okay. Okay. Now I'll come to a question. What is the other name of demux? Can anyone tell? I said mux is also called data selector. What is the other name? Demultiplexer.
Data distributor. Sir.
Data distributor. Okay. Because In Dmux, what will happen is it is just the opposite of multiplexer. Just the opposite of multiplexer. That means we are going to have only one input. I'll go to this slide so that you can understand. Okay. Only one data line or input line will be there. And that particular data, there may be a situation, there may be a task given to us, like we have to route or we have to distribute that particular available single data line to n number of output lines. That means we have to distribute the available input and we have to make the output to be that particular data. So here for demultiplexer also, we are going to make use of selectors. Again, if I want to have 1:4, for example, 1:4 demultiplexer, then I have to go for 2 select inputs, because we have to select to which output this particular input data has to be routed. Okay, that is why it is done. And it is also called, as you said, it is also called data distributor, because we are going to distribute the input data to several outputs. And simply, right, we can call it as one into many. That means only one input will be there along with the select inputs, and that particular input data will be distributed to many outputs. So that's why it's also called one into many. And here also, like multiplexer, we are going to have 1:2, 1:4, 1:8, 1:16 demultiplexer or Dmux. Here also the same thing will be there: block diagram, function table, truth table, output expression using K-maps, and logic diagram. So logic diagram, as far as Logisim is concerned, there are 2 ways to draw this circuit. You might be knowing it, ma'am has taught you, I think, for multiplexer. That means one, I can go for the project and I can build its own circuit by giving various data. அதாவது நம்ம டேட்டாவை மட்டும் கொடுத்துட்டா போதும், இன்புட் என்ன, அவுட்புட் என்ன, எக்ஸ்பிரஷன் என்னன்னு கொடுத்துட்டா போதும், சர்க்கியூட்டை லாஜிசிம்மே பில்ட் பண்ணிக்கும். இது வந்து ஒரு மெத்தட். Another method is we are having gates and wiring option in Logisim. So gates வந்து நீங்க எடுத்து pick and place பண்ணிட்டு, wiring if you give it in the Logisim simulator, it will also give the correct answer. So there are 2 ways, or both the ways are correct actually. But while practicing, you try to practice in both the methods. Okay, whichever thing is convenient during our examination, that we can follow. You understood what I am telling? Okay. So before going into the parity this thing, I want to come to the board now to cover some portions, some additional points about mux and demux. I'll stop sharing this particular screen. Let me go into that thing. Okay. After that, we will come back again. I'll stop sharing this. I'll now turn on my camera. Good. Yeah. Whether the board is visible?
Yes, sir.
Oh, good. See, actually, mux is concerned. For our case, I think you might have seen the implementation of 4:1 mux. Am I right? You might have seen 4:1 mux. Okay. See, simply how to draw its block diagram. Block diagram means, see, I'll draw a simple block so that you can understand. Maybe you might have seen the same thing in theory also, but I'll also teach you once more. So it is 4:1. Okay. Can anyone tell how many input lines will be there here?
4 inputs or 1 output.
4 in 1 output. Okay, very good. See, I am taking 4 input lines like this. Let us take D0, D1, either small letter or capital letter, anyhow we can take. Okay, and I am going to collect only one output, take the output as capital Y. Okay. Now, as you said, for 4, I am going to have 2 select inputs. Am I right? I'll be taking, for example, S0 as LSB and S1 as MSB for my select inputs. Okay. In a mux, normally, other than these things, there will be a pin called E. What is this E called? Can anyone guess? This E is given here a bar, active low signal. Why? Because here there is a bubble. Okay. So to activate this particular IC, this particular device, okay, this particular block, I have to give a 0 signal here. Then it will be activated. So can now you guess what is this E called? E க்கு என்ன பேர் இருக்கும்? ஏதாவது guess பண்ண முடியுமா? You try to guess it, no problem. Yeah, very good. Renuka Devi has given the answer. E here is called enable. Enable input. See, this enable, it can be either active low signal or active high signal. According to the condition available here, we can either make it as an active low signal or you make it as an active high signal. Okay, means, you see, if I want to explain you how the data will be done. For example, these 2 select inputs can have 4 combinations. You know that 0, 1, 1, 0, and 1, 1. Am I right? For example, if I want to select D1 to the output, okay, D1. That is here I want to route this particular data to the output. If that is my task, select inputs has to be chosen like this. S0 we have to choose it as 1. S1 we have to choose it as 0. If this is the select input, then automatically my D1 input data will be selected and routed to. So now what happens for this particular combination is Y will be equal to D1. D1 in the sense, if D1 value is 1 here, then Y will be 1. If D1 is 0 here, then Y will be 0. So this is what is my block diagram explanation. See, I will just teach you what is a mux very clearly. Dmux is just reverse of it. That's all. Just a reverse of it. Okay. I hope you might have understood what I told here. Yeah, Prasanna, any problem? You have raised your hand. Any doubts? Prasanna T.
Sir, no, sir.
But by mistake it was done. Okay, okay, Prasanna, no problem. Yeah.
So
Okay.
please move the camera to the left, sir.
To the left. Okay.
Yes, sir.
Is it okay now? Is it okay, ma? Priyadarshi?
Sir, இன்னும் கொஞ்சம், sir.
Left up now?
Yes, sir, now it's okay.
Okay, fine. Yeah. So this is what is being done over here. Okay. So this is the block diagram of mux. Dmux will have just the reverse of this particular diagram. Select inputs will be there. If I go for 1:4 Dmux, then one input will be here, and here so many outputs will come. Okay. So a very brief explanation I have given it here. Can anyone tell what is the actual meaning, or what do you mean by function table? Function table அப்படினா என்னங்க? யாருக்காவது தெரியுமா? Definition I am asking. Function table அப்படின்னா என்ன? See, function table is a table which is going to explain you the function of that particular device. Function அப்படின்னா அந்த டிவைஸ் என்ன பண்ண போகுது அப்படின்னு சொல்ற டேபிளுக்கு பேர் தான் ஃபங்க்ஷன் டேபிள். சரியா? ஸோ இதுல பாருங்க, ஐ எம் கோயிங் டு டேக் ஃபார் எக்ஸாம்பிள் இ வேல்யூ. ஓகே, சி ஃபார் எக்ஸாம்பிள் இப்போ எனக்கு இது வந்து ஆக்டிவ் ஹை சிக்னலா இருந்துச்சுன்னு வச்சுக்கோங்க. I'll be having a pin like this. Active high. So enable S1, S0, then Y. இப்படிதான் இருக்கும் skeleton of function table. Okay, I think it's visible. இப்போ enable வந்து 0வா இருந்துச்சு அப்படின்னா what does it mean? Enable pinning active high signal இருக்கு, but I'll be giving ES0. That means it will not be activated. Voice is breaking. Okay. Now it is okay.
Yes, sir. It's okay, sir.
Okay, fine. 1 minute. Yeah, now it's okay. Okay. So enable is given as 0 means it is not enabled. That is the actual meaning. Okay. If it is not enabled, then whatever may be the value of S1, S0, output will be 0. See, if I put XX, what does it mean? Don't care. That means whatever may be the value of S1, S0, output will be 0. Okay. If enable, I am making it as 1. Okay. And here, if enable is 1 means what does it mean? Chip is enabled. Chip is ready now. Chip is activated to work. Okay. I am giving here select inputs as this. Again, it is 1. I am giving like this. Again, it is 1, the third combination. Again, it is 1, the fourth combination. What will be the output? Means 0, 0 means D0 will be routed. Here D1, here D2, and here D3. This is what we are going to write it in the function table. Is it okay? Now we are going to write another table which we are going to call it as truth table. Truth table is a table in which output will be derived for different set of inputs. If I give input as 1, what will be the output? That particular thing I am going to write it in a table called a truth table. Okay. Now we will go for writing the truth table for 4:1 marks. இந்த ட்ரூத் டேபிள் தான் நீங்க லாஜிசிம்ல சிமுலேட் பண்ணி பார்த்துருப்பீங்க லாஸ்ட் கிளாஸ்ல. நம்ம அந்த ட்ரூத் டேபிள் இப்ப எழுதலாம். நான் வந்து மக்ஸ் மட்டும் சொல்லித்தரேன். டி மக்ஸ் வந்து இதுக்கு ஆப்போசிட். அது வந்து நீங்களே புரிஞ்சுக்கலாம். சரியா? டவுட் இருந்தா மட்டும் கேளுங்க டி மக்ஸ்ல. Now I will go for the next one, which we call it as truth table. So truth table la skeleton எப்படி இருக்கும் அப்படின்னா enable, சரியா? Then select S1, S0. Then I am having 3 data, 4 data, D2, D1, D0. Then I erase பண்ணிடுறேன். Output is Y. Right? This particular function table, I am going to write it elaborately. That is the actual term. இப்போ enable 0 இருந்துச்சு அப்படின்னா S1, S2, whatever may be the value, whatever may be the value for this D's, whatever it is, I erase it. If S1, S2, all these things are don't care. Whatever may be the value, output will be 0. Why? Because chip is not enabled. Okay. Once the chip got enabled, if these two values are 0, 0, whatever may be the value of these things, and if this is 0, then output will be 0. That means this particular 0 will be routed here. In the same way, if I have 0, 0, don't care. If I have 1 here, then 1 I'll get here. Again, enable is 1. If I make it as 0, 1, don't care. Here, if it is 0, this is a don't care, output is 0 because this value is rooted here. Then next combination. If this is 1, output is 1. 1, 1, 0, x. If this is 0, if this is a don't care, then 0 will be here. See, I am writing very faster due to my practice. If you have got any doubt, you can ask me. Going for last two combinations. If this is 0, these are don't cares, 0 will be there. 1, 1, 1. If this is 1, these are all don't cares, then I have 1. So this is my truth table, which I'm going to write it for a multiplexer. 4:1 multiplexer. Any doubt in this? Now we are going to write the output expression for y. Okay, how that can be written, that we will see. How y can be written. See, in this particular y column, you look at this particular column, y column. Okay, here how many ones are there? You just have a glance. See, here there is a 1, first one. So one corresponding data or enable is 1. That means E. S1, S0 are bars. So S1 bar, S0 bar, and D0. D0 is 1. So if this is the combination, then output is 1. Next one is coming over here, where plus E, S1 bar, S0, D1 will be there. Next one is over here, E, S1, S0 bar, D2. Last one is E, S1, S0, D3.
D2.
This is the expression for Boolean expression for output. Is it okay? இது வரைக்கும் யாருக்காவது டவுட் இருக்கா? இப்போ இதைத்தான் வந்து நம்ம என்ன பண்ண போறோம் அப்படின்னா, we are going to implement in the logism. அதை ரெண்டு விதமா பண்ணலாம். ஒன்று வந்து நீங்க பாருங்க, இதை வந்து AND கேட் ஆர் கேட் யூஸ் பண்ணீங்கன்னா யூ கேன் டிசைன் ஆன் யுவர் ஓன். அதர்வைஸ் இன்புட்டு அவுட்புட்டை நீங்க டிஃபைன் பண்ணி பில்டு சர்க்கியூட் கொடுத்தீங்க அப்படின்னா லாஜிஸுமே உங்களுக்கு சர்க்கியூட்டை வரைஞ்சு கொடுத்துரும். இவ்வளவுதாங்க. இதுல ஏதாவது டவுட் இருக்கா யாருக்காவது? இப்போ இந்த எக்ஸ்பிரஷன்ஸ்க்கு வந்து if I want to draw, right, if I want to draw the logic diagram or implementation, how it will come, that also I will draw it here because நம்ம ஒன்ன பார்த்தாலும் ஒருபடியா பார்க்கணும் இல்லையா? மக்ஸ் வந்து இதுக்கு ஆப்போசிட்டுங்க, that you don't bother. Okay, இதுக்கு just opposite அவ்வளவுதான். இதோட லாஜிக் டயக்ராம் இப்போ எப்படி வரும்னு பார்க்கலாம். நான் என்ன பண்றேன், இங்க எனேபிள், நம்ம அதுல டயக்ராம்ல வேற மாதிரி போட்டிருப்போம். நான் இங்க எக்ஸ்ட்ராவா எனேபிள் பின் எடுத்துக்கிறேன். ரைட்டா? Then I am having S1 here, S0 here. So S1ங்கிற பின் இங்க இருக்குது. S1க்கு நாட் கேட் போட்டு ஒரு லைன் வச்சுக்கிறேன். S0ன்னு ஒரு பின் இருக்கு, இதுக்கு ஒரு நாட் கேட் போட்டு வச்சுக்கிறேன். ரைட்டா? இதை தவிர பார்த்தீங்கன்னா I am having D3, all the 7 inputs, D2, D1, D0, இதெல்லாமே இருக்குங்க. ரைட்டா? இப்போ ஃபர்ஸ்ட் வேல்யூ என்னங்க? E. So E is here. If I am having 4 input AND gate, how I will draw the circuit? E, S1 bar, S0 bar, D0. இந்த நாளையும் AND பண்ணிக்கணும். எல்லாம் மல்டிப்ளிகேஷன் தான். கரெக்டா? அடுத்தது பிளஸ் என்னங்க? E. இது வந்து ஒரு விதமான சர்க்கியூட். இப்ப நான் வரையறது சரியா? S1, S0 bar, D1. ஓகே, ஸோ இதை வந்து நான் AND பண்ணிக்கிறேன். If I am having a 4 input AND gate, I can do it. அடுத்தது E, S1 Here actually S1 bar, here S0 bar. I think this should be 0, 0, 0, 0, 1. Yeah. Okay. இப்போ வந்து E 1 0 1 0 D2 இதையெல்லாம் ஆட் பண்ணிக்கிறேன் சரிங்களா ஃபைனலி E S1 S0
D3.
இதெல்லாம் ஆட் பண்ணிக்கிறேன் இதெல்லாம் என்ன பண்ணணுங்க டோட்டலா I am going to என்ன பண்ணணுங்க என்ன கேட் பண்ணணும் எல்லாத்தையும் ஆட் பண்ணணும் இல்லையா so we have to go for a OR gate இது எல்லாத்தையும் ஆட் பண்ணணும் அவ்வளவுதான் இங்க கிடைக்கிறது தான் உண்மை இது வந்து ஒரு ஷார்ட் ஆஃப் டயக்ராம் இது யாருக்கு புரியலம்மா இந்த லாஜிக் டயக்ராம் யாருக்கு புரியல யாருக்கு டவுட் இருக்கு இதையெல்லாம் நம்ம வந்து we have done it in the Logisim நம்ம லாஜிசிம்ல வந்து எப்படி போட்டுருக்கோம் அப்படின்னு கேட்டீங்கன்னா எல்லாம் வெர்டிகலா எடுத்திருக்க மாட்டோம் எனேபிள் பின் எடுத்திருக்க மாட்டோம் சரியா S1 S0 எடுத்திருக்கோம் D3 D2 D1 D0 எடுத்திருக்கோம் 3 இன்புட் AND கேட் அண்ட் ஃபைனலி OR கேட்டை யூஸ் பண்ணிருக்கோம் அவ்வளவுதான் சரிங்களா இதோட ஜஸ்ட் ரிவர்ஸ் தான் வந்து demultiplexer ஓகே so I'll give you some brief about demultiplexer also demultiplexer na logical போண்ட but I'll be telling what does that particular thing is going to do so அதுலயும் நாலு விஷயம் நம்ம எழுத போறோம் number 1 it's what we call it as it's block நான் வந்து இப்போ 1:4 எடுத்துட்டேன் நம்ம கன்வீனியன்ஸ்க்காக 1:4 Dmax இதுக்கு பிளாக் டயக்ராம் எப்படி வரும் அப்படின்னீங்கன்னா there is one block diagram 1:4 Dmax we call it as இங்க ஒரு enable pin இருக்கும் எத்தனை select inputs இருக்கும் ரெண்டு இருக்கும் ஒரே ஒரு input தான் இருக்கும் we call it as D and we are having 1:4 அப்படின்னு கேட்டிங்கன்னா we will be having 4 outputs we call it as y3 y2 y1 y0 y0 ங்கிறது LSB y3 ங்கிறது MSB ன்னு எடுத்துக்கோங்க இப்போ according to the select inputs this data will be distributed for example நம்ம நார்மலா இங்க வந்து நம்பரை மாத்தி எடுப்போம் இல்லீங்களா அது எப்படி வேணா எடுத்துக்கலாம் நம்ம கன்வீனியன்ஸ் தான் but you have to define like which one is MSB which one is LSB இப்போ for example இங்க 1 1 இருக்குன்னு வெச்சுக்கோங்க எனக்கு select inputsல அப்ப என்ன ஆகும் அப்படினா இங்க இருக்கிற இந்த டேட்டா வந்து it will be routed to y3 புரியுதுங்களா it will be routed அவ்வளவுதான் so இப்போ இதுக்கு ஃபங்க்ஷன் டேபிள் எப்படி வரும் just opposite of என்ன அவ்வளவுதான் மீன்ஸ் ஃபங்க்ஷன் டேபிள் பாத்தீங்கன்னா நான் fn டேபிள் அப்படின்னு போட்டுக்கிறேன் இதுக்கு எப்படி எழுதலாம் அப்படின்னா enable s1 s0 y0 y1 y2 y3 it goes like this enable 0-வா இருந்துச்சு அப்படின்னா இது எல்லாமே 0 தான் enable 1ல இங்க 0 0 இருந்துச்சு அப்படின்னா y0 will have d value என்ன d small d ஏன்னா என்னோட input data வந்து small d மத்தது எல்லாமே 0 தான் கரெக்ட்டுங்களா இங்க 1 இங்க 0 1 அப்படின்னா இது 0 இது d இது 1 0 அப்படின்னா இது d இது 0 இங்க 1 1 அப்படின்னா y3 வந்து d அவ்வளவுதான் இதான் ஃபங்க்ஷன் டேபிள் இதை எலாபரேட் பண்ணி நீங்க எழுதுனீங்கன்னா ட்ரூத் டேபிள் will come to you ரைட்டுங்களா சோ அத வந்து நம்ம சிமுலேட் பண்ணாதான் வந்து what we have done it in the last class do you have any doubt in this multiplexer demultiplexer theory parts
No, sir.
okay so implementation la yarkavadhu doubt irukappa any doubt in the implementation part of mux and dmux 4:1 mux and 1:4 dmux using Logisim simulator. Any doubts anybody has got? Whether we have to run it again or it is enough? Raylin Celicia, she is telling like no sir. No sir. Okay. As time is up now, we will stop here. And next class, we will be seeing the next experiment, parity. Okay. So what a small task I want to give it to you. That is, you Google it and find what is the significance of having a parity bit. In computer science engineering, normally they will speak about pockets, data they will be sending by means of packets, right? Right. So along with that particular packet, they will send one extra bit, which we call it as parity bit, okay, to find whether there is any error, to find whether there is any error in the sending data. Okay, so in sending side and also in the receiving side, they will check that particular parity. Okay, so for error detection and for error correction, for these two purposes, parity bit will find its application. It's find its uses. Okay, this is a small bit of information I have given it to you all regarding parity. You Google it before coming to the next laboratory session, that is on coming Tuesday, and you share what you seen in the Google. Okay, and then we will try to complete that particular experiment on that day itself. Okay, so with this particular point, I want to close this particular session. We will meet once again on Tuesday, that is on 7th of September, with a new experiment. Thank you all.